Hello everyone, in the last tutorial we stopped at the point where we modeled the Raft foundation on the sand layer, and we found that the amount of displacement comparing to the displacement using Plaxis 3D, it was same, and Midas GTSNX more representative for the output. We can create a lot of complicated geometries. We have a lot of different soil models with different materials and different isotropic and orthotropic materials. Besides them, other advantages over the Plaxis. In this tutorial, we'll start to update our model to include piles. So we will go back here and we will start to delete all our meshes, and we just go back to show the geometry. So here we will start to go back here and we'll start to create one 3D line. So from here we create a line with 0 and minus 20, and we start to take this line and we move it using translate, and we choose the direction we choose this direction, and we translate it in y direction, distance equal 1, and we say apply, and we select it again, and in x direction a distance equal 1, and we say apply. Now I will start to hide this, and this is my pile. So here I will start to create a copy of this pile, translate in this direction. I will copy it 2 meters 5 times, just 4 times, sorry, and I say apply. I select all the lines here and I copy them 2 meters 4 times in this direction, and we say apply. Now we created the lines to be meshed for the piles. These piles are, as we can see here, they are 20-meter length. So all we have to do now is show everything, and I will create a surface here using polyline. We create a face, and I will start to translate this face in this direction, a distance 21 meter to the base of the pile, and we say apply, close. We can come here and we control the transparency of the pile, as we can see here. And we start to divide this solid using this surface, and we say apply, cancel. A very important tool here is called Imprint. So all we have to do here is to imprint this pile on the surfaces. So I will start to choose imprint, and I go to curves, and I select my piles. From curves here, this is my tools, and I'm selecting those surfaces, and I am selecting this surface, and we choose the shortest direction and we say apply. As we can see now, we are creating that this pile feel that it's connected to this soil. So like if we set hide here, we can see the marks of the pile imprinted here. As we can see their location, and if we hide those and we looked here, we already imprinted on this surface and the other surface, so we can just hide those and hide those, and we just show the solids, and those piles are already imprinted here. So now I will start to create auto connect, apply, then I save my model. Then now I will go to here to material. The pile is concrete. I will leave the material properties and I will start to create 1D, and it will be embedded beam. The spacing will be unknown here, as will be solid round, and it will be 0.8, and we'll say OK, and we will call it as pile. This is all the properties, the cross-section area and everything, and we say apply, close. Now I can go here and I start to mesh everything. So I will start to mesh everything. So I will go here and I will select, sorry, here mesh, and I will start. Before this, now we will start to mesh. So we go to 3D and I choose my Raft and I say 0.25 and it's soil, and I say Raft, apply, and I choose my soil section and we say soil. It will take a moment. I will just stop this because it's very small. I choose it like this, and this is tetrahedral again. I prefer tetrahedral, show all. I choose this and I call it Raft, and this will be 0.25 and I say apply. Then I choose this and I call it soil, and this will be 2 meters, and we say apply. This takes time because it makes a connection between the pile and the soil element and the raft. Now it's done. Go to 1D element, choose all the lines here, pile, and we call it pile, and we say apply. So this is our pile. Now we will start to go to create a gauging shell. So I will go to create other gauging shell, and I will update this, and I choose that. I select this surface and I say apply, and I go now to boundary condition, set my boundary condition, and I say apply and change boundary condition for the raft. And I say apply. Then finally I go here to create this. Since we updating the other model, it might be here. Yes, it's here, and we can start to add live fluid again. It will be here because of we already added it to the solid and we didn't remove the solid, so it will be there. We are not gonna change it. Now we will go to the construction stages, and in the initial stage we will add the soil and the raft, and boundary condition and the gravity load will be the same, and I say save. Then I go to the structure, it will be here piles, and there is gauging shell and the boundary condition for the raft, and I say save. And finally is the load. We can come here to simulate the stages. As we can see here, we just revising. This is the pressure, this is the gravity, this is the boundary condition, we delete it, and this is the raft boundary condition. So we go here and we choose raft and create raft, and we select this one. Sorry, we select raft and we say apply, and let's revise. Then at the initial stage, change and piles and load, and we say close. It's gonna be the same case, so we are not gonna change anything. All we have to do now is to run our model and to see the difference. I finished my run here and I don't have any warning. The time, as we can see here, is a bit higher, and this is because we included other element in the domain. But now we will go to see our results for the load and the total displacement. As we can see here, the displacement has decreased to almost 3 centimeters, and it's comparable to Plaxis too, because it was about 3 centimeters. And now we can see the effect of the pile and including the pile in our problem. We can see here that we can present all the results for the stresses and for the strains, and As we can see here, we can see the plastic point. We can see here, this is the point reached to the plastic state. We can see von Mises stresses. We can see the effective stresses here again, and we can see that the maximum stresses here appears in the concrete, and makes sense because of the load. And if we remove the raft, we can see that the maximum stresses here appears in the soil, and the maximum stress is 60 and it just beside the raft, and makes sense because of the transition of the loads. Now we can look at the results again, and we can look here at the gauging shell, and this is the moment. As we can see, this is a negative moment, and this is a positive moment in between the piles as plexes, as we mentioned this before. And we can see that the maximum and the minimum moment, we can use prop here to put values on the here, or we can use cut diagram to create the surface, and we show it in, let's say, y direction, and we say apply. As we can see here, this is the moment in between the piles, and let's say we can create another cutting diagram at this surface and show it in y direction. We can see here there is positive, like the variation of the moment due to the pile. And if we take another cutting diagram here from this point to this point, and we showed it in x direction, we can see the difference in the results and the positive and the negative moment. We can see here also the pile, and we can go and look at the maximum displacement. Here it's almost 3 centimeters. We can look here at the beam forces, so we can look at the axial force, the distribution of the axial force, and the shear force in y direction, and the bending moment in z direction. And there is and we can see all the results we need to look at. And as we can see here, that Midas is very flexible in representing our result, and it has, as we mentioned before, a lot of constitutive models, and it has a lot of ways to present our results, which make it very competitive to other softwares. I will stop this lecture at this point and see you in next lecture. Thank you.